Welcome back to the White Coat Club. This is Lindsey and Nicole here today to talk a little bit about research. And today we also will be talking with a special guest named Shvetali. She is one of our instructors for the Rising Researchers Program, and she's also an essay coach and mentor at MoonPrep. And so she'll be diving a lot into some of the offerings of rising researchers and also talking a little bit more about the importance of research into BSMD programs. Before we get started, don't forget to like and subscribe to get more BSMD and med school admissions advice. Okay, so Shvetali, do you mind introducing yourself and telling us a little bit about your research experiences?
Absolutely. Thank you for the introduction. My name is Shvetali, and I am a second-year med student at Case Western Reserve University School of Medicine. I graduated from Case's undergrad program in May of 2022 with a Bachelor's of Science in Neuroscience, as well as minors in Economics and Chemistry. I took a year off between undergrad and med school where I worked at Horizon Therapeutics as part of the corporate social responsibility team. And I am currently working on otolaryngology and neurosurgery research in med school with a hopeful interest in going into ENT.
Okay, so of course at MoonPrep, we work a ton with BSMD students. And I feel like the big question, especially for our younger students, is how important is research for BSMD? So typically, what do you say to students as you're helping them prepare for BSMD applications?
So, research is pretty heavily weighed by many BSMD programs. It's an opportunity for students to show a lot of different skills, and I think that's why it's something that's valued in the BSMD community. It shows your ability to kind of apply knowledge that you've learned in the classroom to more real world problems, and it also shows your proactiveness to kind of take on these experiences outside of what's expected from your high school curriculum. And simultaneously, it shows your ability to communicate scientific information concisely, as well as critically appraise the literature that you might be reviewing, the experiments that you might be helping out with, and to just kind of overall get the sense of what does research and science look like? Because research is such a huge component of what drives advancements in medicine. And it's something that's really valued by a lot of residency programs, by a lot of med schools, and it's something that's really important as a physician to be able to not just perform research, but also to be able to appraise research and be like, hey, is this treatment something that I could maybe consider for my patients? And that's something that goes a long way in your career in medicine. So that's a little background for why research is so important when you're applying BSMD. Now, in terms of like how much of it you should do, I think it really comes down to just showing initiative with research. It's very variable how much experience you can get. That kind of depends on your location, what institutions are near you, what the policies for research are at those institutions, and schools are mindful of that. But what they really want to see is that you've taken the time to complete some kind of research and you've done some work in being able to apply what you've learned in the classroom and take it to the next level.
I feel like research is such a good way to demonstrate like intellectual curiosity, because you're able to dive outside of like AP Bio or microbiology classes, like at your high school, and lets you really hopefully apply some hands-on knowledge there. And so that's, I think, one of the big values of research. And as kind of mentioned too, like some programs will value it more than others. And we definitely have had some BSMD students who've had absolutely no research on their resume. And we've had some BSMD students that have had a ton of research on their resume. So it just kind of depends like which programs they care about and which ones they really do value. Like, for example, there are some programs where I feel like research is kind of like a non-negotiable. Like, for example, Case Western is always one that is like, you really do have to have some research. And same thing with like RPIs, their physician scientist program. Of course, they're really looking for kids that have like research experiences. But then we've talked to programs like VCU where, they'd rather see community service and like clinical hours than research. And so it will vary from program to program and school to school. But I would say overall research is always like a good thing to have on the resume. And what type of research do DSMD programs typically accept?
I think they're pretty like broad in what they accept for research because they know that it's hard for high school students to necessarily like find specific opportunities. And there are restrictions for things like wet lab research and what kind of wet lab research high school students are allowed to do. So in general, I don't think that they are like limited in their scope of the literature that the research that they accept. Some examples of types of research that students will participate in includes traditional wet lab research. This can include a biology lab where you're working with cell cultures or you're pipetting. It can include labs within chemistry or physics. And even though physics might like off the top of some people's heads, they're like, that's not really medicine, but a lot of physics can play a role in medicine, especially with things like nanoparticles these days. So that's just to say, you can kind of go whichever way with like wet lab research that you want and what kind of piques your interest. So pick the field that's most intriguing to you and not necessarily what you think is going to look best for colleges, because a lot of research in a variety of fields is contributing to medicine in some way. Students can also engage in public health research, and that can look like doing work with policy, can look at doing like population level data collection and data analysis. You can look at public health interventions that can include things like food deserts, food pantries, implementing more like clean water programs, etc. So it's like it's very broad on how that can go. And then with something that sometimes doesn't necessarily require as much of like in-person commitments or like data access specifically. Students will also write literature reviews. Literature reviews are a great way to show your own initiative and proactiveness without necessarily having a specific like lab that you're able to join, because oftentimes you can do most of the work for literature review on your own from home. You're really just scouring the literature for a specific topic and trying to write a article that kind of answers a specific question. And that's something that a lot of PIs will be willing to kind of guide you through. So that's a good way to start if you're not sure whether you want to join a wet lab or something else.
Especially if you're young. Like a lot of, I know you mentioned this, but I'm going to reiterate it too. Like a lot of times you do have to be 16 or 18, which obviously a lot of our high schoolers are not, to be in a wet lab. And a lot of the times, I think like the best way to really get involved in research too, especially when you're young, is not necessarily like cold emailing places. It can totally work and could be good. But like a research program can sometimes be like a really great way to get like that wet lab experience, because then you have a dedicated person who's there to help you and to guide you. It's a lot to kind of ask someone to train your untrained teenager for free in like their lab. And so, take into consideration this is their job and like this is, what they're trying to achieve. And, it's not that every single student can come into a lab and have a good experience. It does take a lot of time on like the PI's part. So that's why I think sometimes research programs can be a good way, unless you know someone, or at least like, maybe you do have a good contact, it can work. But programs I think can sometimes be the best way. And kind of on that vein, we definitely will talk a lot about a virtual program here shortly with rising researchers, but do you think that there's any like disadvantage of virtual programs, or should we only be doing research in person?
I think they offer different opportunities. You're obviously not going to be able to learn how to pipette and culture cells virtually. And those are skills that can be valued in certain labs, or skills like microscopy, cytometry. Those are things that you're only going to be able to gain in a wet lab. But I think the general principle of what BSMD programs are looking for with research can be attained from both experiences. One might give you more hands-on experience, but with virtual experiences, you can also collaborate with PIs or instructors that are from around the country, and that's really helpful in terms of like finding things that pique your specific interest. It's also something that kind of allows you to jump into the literature game a little earlier, and it's very hard for like students to specifically understand certain niche topics right off the bat, like a specific like molecule or its inhibitor. That's very difficult to like contextualize at the beginning. So sometimes virtual programs are great for getting like a overarching theme of like a certain field of interest, for example, and then funneling a little bit deeper into something that captures your interest without necessarily having to commit to it right off the bat with a in-person lab. In general, they're both going to show your proactiveness. They're both going to allow you to demonstrate your scientific writing and your ability to apply classroom knowledge to real world scenarios. So I think they both still achieve the general principles of research that are expected from applicants for BSMD programs.
So I know you kind of mentioned a little bit about the skills that you would learn, but do you think that the research topic specifically matters?
I really don't think that there's anything that you could do research in that wouldn't necessarily be like something that the med school consider or the BSMD program considers like a strong research topic. I think it's really just a matter of finding research that interests you. And the really big thing is that whatever research you participate in, it's something that you want to be able to talk about. So during your interviews, it's something that's going to come up if you have it on your resume. They're going to ask like a few questions about like, why did you do this? Or what did you learn from this? And that's when it's really important that you're able to explain your research topic. So finding something that sounds really fancy, but you have absolutely no idea what you're doing with it isn't going to go a long way when it comes to the interview and you're not really able to explain why or what exactly you were doing. So it's much better to find a topic that you understand. It's something that's of interest to you, and it's something that you're going to be able to contribute to in some way. And oftentimes that's a lot harder to do if you're picking a topic that's like entirely new to you. Whereas if you've had a little bit of background, for example, with like proteins, and then you do research in proteins, you have a little more context for that, as opposed to picking a very specific like drug and its target that you've never ever heard of in your normal science classes. So I think in short, the topic itself doesn't matter, but that's just a little bit of advice for identifying a topic that will make it much easier for you to communicate during your interview process.
That's
Yeah,
helpful, you
yeah,
know.
and sometimes you have no
Yeah.
choice too. Like, you might not have any options about what's available. Like if you are in kind of a more like isolated spot where you only have access to like one or two like universities or labs or things like that, you might get what you get. And that's what I always tell students too. Like try and find something that fits your interest, but if not, it's okay.
Yeah, I also think it's like a time to explore. You know, some of our younger students sometimes are so picky and, you know, considering a lot of things have age restrictions, like kind of if this was being offered to you, this is what's in front of you, don't just rule it out before you try it and, you know, kind of see. How long do you think that the research experience should be kind of to make it meaningful? I know you said that any topic would really be meaningful, but you know, if a student's able to just do like 1 or 2 days in a lab, is that going to be something that's a good experience, or do you think there's like kind of a timeline or a specific time frame students should be doing this?
So in general, I think research experiences are something that need to occur over a significant period of time. Um, I think like 4 weeks of dedicated research is a good example of like spending enough time. Obviously, colleges are mindful, like students are full-time students in high school. They have other obligations, they have like sports, they have clubs, they have other volunteering activities that need to be participated in as well. So they know that research cannot be your full-time job of 8 hours a day, 5 days a week for a certain number of weeks. But in general, I think like aiming for 4 weeks in the summer at minimum of dedicated research can be helpful in being able to kind of like really learn what you're researching and being able to like have something meaningful to contribute. Obviously, the longer the better. So if you're able to like work 8 to 10 weeks in a lab, like that's great. But sometimes that can be a little unrealistic. So I think trying to communicate that ahead of time with the lab that you're considering joining or when you're reaching out to your PI to kind of suggest that, like, hey, I'd like for this to be a longitudinal thing. Does this timeline work for you? And if it's not something that's happening over the summer and instead it's something that you're able to do during the school year, it's okay to work on it only like once a week or twice a week, but have it go on for multiple months because then you're still spending a lot of time on it, even if it's not every day. I think in general, whenever you're looking for a research opportunity, try and have some form of an end goal, whether that's like having a short literature review done at the end of it, or whether that's having a small little data set that you're able to talk about at the end of your 4 weeks or 8 weeks, etc. But whatever that may be, or if it's like a poster that you're going to present, whatever that may be, you want to have something that you can kind of like use as like a endpoint, and then you're able to talk about like this is how it started, this is what I did in the middle, and this is what I finished with at the end when you are asked to speak to your research experience.
That's helpful too. I think a lot of students really, again, kind of getting back to what we said before about being a little bit picky. Like some students are like, I don't want to do a formal program. I want that it's going to be longer over time. And then they reach out to maybe professors, and the professor or the, researcher is like, you can do one day here if you want to kind of shadow, but that's probably not going to be nearly as meaningful as something like you said, over time, spending the longevity doing it, even if it's a virtual program.
And speaking of virtual programs,
Yeah.
good transition into there because we can talk a little bit about Rising Researchers, which is coming up in the next month-ish or so, I guess. It will be taking place like starting in mid-December. So Rising Researchers is like one of our sister companies here at MoonPrep, and Shvetali is one of the instructors. So I'll kind of explain like a general format of it, and then Shvetali, I'll have you dive a little bit more into like your class because we do have two different class options. But in general, for Rising Researchers, our winter camps this year will be 8 sessions. You'll meet 2 times a week that are like predetermined times because they are classes. And each class is about an hour and 15 to an hour and a half. Um, the result of the program is, always our goal is to help you get a guaranteed publication. Now, this guaranteed publication does have a few like caveats because, of course, you do have to be actually producing the work and you need a grade of B or higher to be published in the journal. But we do work with all students to make sure they do get to that finish line. And so, as long as you're willing to put in the work, you will get published essentially because you'll be working with your research mentor over the 8 sessions on the literature review paper. And you'll also do a poster presentation too. Then lastly, kind of one deliverable that all the classes will have is that you, at the end, any eligible student, and eligible means you got a grade of B or higher, you can request a strong tailored letter of recommendation letter that you can be submitting to colleges or other like summer programs or whatever you want. And so this one will help to recognize your accomplishments, any unique characteristics or, different qualities maybe that you showcased in the class and throughout your project. So essentially, if you participate in a Rise Your Researchers program, you can ask for a letter of recommendation, you'll have a publication, and you'll do a poster presentation as well. Now, Nicole, do you mind maybe explaining about the 2 research topics that Jetty will be doing?
Yeah. So Jetty, who is a professor at UMass, is teaching 2 classes this upcoming winter session. They are both the same topic. It's going to be on medical and bioinformatics research, doing data analysis on human disease or a microorganism's impact. So she's done this a couple of times. She's been with us or with Rising Researchers since the very beginning. It's been quite a few years now that she has been with us. She teaches a really great class. She's extremely insightful, and her sessions are going to be the same thing, kind of starting in that mid-December time.
And if you want more like specific info about when the classes start, check out our website, the Rising Researchers website, just www.risingresearchers.com. They've got all the details about the class times and the class
More of the
dates.
syllabus too, of
Mhm.
yeah, kind of the specifics of what you'll learn.
Like the outcomes and things like that. So yeah, a lot of good information. I think like one big question we always get asked too about this one is how much experience do I need to have? Because it is bioinformatics and you are using like AI and machine learning. But the good news is you don't have to have any prior experience for either one of these courses. Jetty will teach you what you need to know, and it is like a no-code bioinformatics platform that's used by scientists. And so no prior knowledge is needed at all. So no matter what you are, or no matter where you are in the process, if you're, a ninth grader who's never taken any like higher level science classes, or 11th or 12th grader who has, you can still be learning and be challenged by this course.
The other thing too, I also feel like we get the flip question of like, well, is this going to be too introductory for like an 11th grader who does have some experience already? Shetty does a really great job of kind of meeting the student where they're at. She's really able to kind of challenge the ones that are prepared for it, meanwhile keeping it introductory for the ones that are not so confident in their skills just yet. So she really does a great job of just meeting the high school kind of class in general, and kind of tailoring it per student.
Cool. And then we have another session as well that we're offering this year. This is our first year of really offering multiple winter sessions. So Shvetali, you are teaching our second session. Do you mind telling us a little bit about your class?
Yes. So my class will focus on exploring topics in neuroscience as well as a few research methodologies in neuroscience. And the outcome of this class will be a publication that is writing a review article on a topic in neuroscience. So to kind of break that apart, in terms of topics in neuroscience, there's a lot of different subfields within the big field of neuroscience. And I hope to kind of give students an overview of that. I know that neuroscience is a hot topic these days, and as someone who majored in it, I'm very passionate about it. So I'm hopeful about teaching how there are different aspects of each subtype and what kind of like both wet lab research and clinical research opportunities lie in each of those fields. And this is great for students who are looking to learn a little bit of just general neuroscience background and then like what things they might be interested in within the field of neuroscience, especially for students that may be considering a possible major in neuroscience. This is a great opportunity to just kind of like learn like, okay, so what exactly is it and what can I do with it? And then in terms of research methodologies, that is something that we will look at different types of like mice work versus tissue work versus computational modeling. I cannot obviously teach all of these things within 4 weeks, but I hope to at least provide an overview of what those different methods look like and when they might be used in different neuroscience fields. And then ultimately, with this knowledge, students will work on a review article throughout the 4 weeks, and that will include basically identifying a question within the realm of neuroscience that they're interested in. So, for example, it might be, what are the pathways that contribute to intrinsic motivation? That is an example of a certain kind of question that is a specific type of neuroscience. In this case, that would be falling under motivational neuroscience. And after that, we'll kind of have portions of the class that are dedicated to the different aspects of a review article. And then students will work on these as homework, where they will explore the background on the topic. They will find specific literature that kind of answers the question that they've come up with. And you can think of a review article as a summary article that responds to a specific question. So you're taking all of the literature out there that is relevant to a question that you're asking, and you're going through it and you're writing a summary article that is able to concisely explain all of this information. And that's the article that students will ultimately be publishing after they meet all of the benchmarks.
Perfect. And so once again, it sounds like they don't really need any prior knowledge, just like a willingness to learn. Is that right?
Absolutely. I do think that a disclaimer that I put on the course guidelines is that it is recommended for students to have taken at least one high school level science course, but by no means should it be in neuroscience specifically. So physics, biology, chemistry, any of that works, but just to have had some exposure to high school science.
Love it. Yeah, so it could definitely be either a good starting point for kids who haven't done research or just want to specifically explore either neuroscience or maybe bioinformatics with Jenny's course. I think that's it for us today. Thanks so much for joining us, and hopefully you can join us at a Rising Researchers Camp as well. If you want more information about Rising Researchers, you can find more information about it on the MoonPrep page, or you can just go directly to risingresearchers.com and find out more information about the camps, any other upcoming offerings that they might have. But until next time, make sure to like and subscribe to get more great BSMD and college admissions content. See you next time.